Okay, so this episode is quite a short one, but it covers a quite interesting statistics question that I came across. So in this particular statistics question, we're looking at cost and real-world applications. So people have gone out, they've looked at a certain brand of staplers, obviously the people who own the company, and they've determined some values about the mean and the standard deviation. Now, it's part of life that products won't always work as they are intended to function, because, of course, they may break after a little while, or they may be slightly faulty. So because of that, you can't necessarily predict how much profit you're going to make if you're going to have to provide a replacement, especially if you offer some form of guarantee on your product. So with this in mind, what we're going to have to think about is, of course, well, what proportion of these staplers, in this case, are going to fail, and how can we calculate our profit by knowing the mean lifespan of the stapler and by knowing the standard deviation from our testing. Of course, we're going to assume that it's a normal distribution and not some complex form of distribution, but it's quite important that we consider, okay, what proportion are going to fail and how much is it going to cost us. So again, for the purpose of this statistical exercise, we'll just assume that one replacement is given, not multiple replacements. So, in order to do this, we have to first read through the question and identify the key values associated here. And it is different from your typical statistics question because we have prices involved, along with a mean and a standard deviation. You're also going to need to know cost terms as well, like what is revenue? Revenue is the sheer amount of money you make before you pay back the expenses. So revenue is just how much money you're going to get before you pay back what it cost you to make it. And profit is, of course, how much you actually make after paying everything back. So for this case, we're going to assume that we're not really paying anyone wages here, and that the profit is sheerly how much money we're going to get after we've paid back our expenses, and after we've given the people who got a dodgy stapler a replacement. So identifying key values. Question again talks about staplers. It says that they are manufactured for $5. That's the cost to the manufacturer. So for each stapler made in a factory, it's going to cost them $5. Part of that is probably a labour cost. Part of that may actually take into account the wages that people are given. But we can only assume values based on what's given in the question. We can't say, well, okay, we should add an extra bit on the end there to say the average wage is such and such and there are so many people in the company. Again, that may be taken into consideration there, and because it isn't part of the question, we can't assume that kind of value. So when we are thinking about how much revenue or how much profit we're going to make, we assume that the values given will allow us to get the profit without any extra values on top of that. So it says that these staplers, after being manufactured for $5 each, are sold for $20. So they're sold for 4 times the cost that it was to make them. Staplers are guaranteed to last 3 years. Okay, so they've gave a 3-year warranty, and they'll probably replace the staplers that are faulty within 3 years. The mean life of a stapler is actually 3.42 years. And they've gone out and they've done some testing and they've found that the standard deviation is 0.4 years. So right before you go and consider what that actually means as well, you're going to obviously see, well, if the mean is 3.42 years and standard deviation is 0.4 years, then you know that the mean is 3.42 and that the standard deviation is 0.4. So you know that you're going to be looking at just under 1 standard deviation below the mean as actually being the boundary line from the proportions that actually need to be refunded because they're faulty. And again, that's a good way to think about it in stats. What kind of values are you expecting? So obviously we wouldn't expect more than 50% of the staplers to be faulty. But again, we'll come back into that later after we've gone through the question and we've finished identifying the values. So again, we know the mean is 3.42 years and we know that standard deviation is 0.4 years. So when, assuming this is normally distributed, how much profit would we expect from selling 2,000 staplers? And again, the question actually gives us something that's really helpful. It assumes that one person will only get one faulty stapler. It'd be very unlikely, as we'll probably see in a minute, for a person to get a faulty stapler and then another faulty stapler. However, we will actually calculate that. There's a little extra on that. But again, it just assumes, for simplicity's sake, because obviously we'd have to keep adding in variables, but for simplicity's sake, we just assume that they'll only get one dud. Okay, so first off, let's calculate revenue. Because we know that revenue is going to be a good indicator of how much money we're going to get total. Now, revenue is, of course, going to be the number of staplers we have multiplied by what we actually sell it for. Now, our profit is going to be based on 3 different variables. It's going to revolve around our revenue. We're going to have to subtract the cost of producing the staplers, and also the replacement cost. And that is the cost of actually providing people who get a dud with a new stapler at no charge. So now that we have those 3 values in mind, we can calculate revenue from this, and we know that 2,000 is the number we're making, and we're selling for $20 each. So if we were to work that out on a calculator, we would get that the sheer revenue is $40,000 from our stapler company, which, you know, is probably pretty good. If they were to, obviously they'd need to sell other products as well if they needed to pay wages and things like that. But it's a good start, especially if it's just a small-scale business or something. Now, let's have a think about some of these other values here. Let's consider cost, because that's another easy one to calculate, because we have all the values in there and we don't need to think about proportions or anything. So when it comes to the sheer cost that it costs us to produce those 2,000 staplers, wherever they're made, maybe in a factory or something, we simply go, okay, well, there's 2,000 staplers being produced and it costs us $5, so the actual cost to us for having those staplers made is $10,000. And hence, we have got our 2 crucial values that help us work towards calculating the profit. We've got 40,000 as being the revenue, and we've got the cost as being 10,000. And we know we're getting there, we just got that one last value. So in order to clear off a bit of board space now, what I'm going to do is I'm going to put these values into the profit formula, and then we're just going to have a bit more room to go through a few things. So as I said before, profit is of course cost. In fact, I'll say revenue, subtract cost, subtract replacement cost, and we know that that's obviously going to be 40,000, take 10,000, and then subtract replacement cost. Now, as I said before, when I drew up that little diagram, and I said, well, we know the mean is obviously 3.42 years, and we know that one standard deviation is 0.4, so we know that the actual proportion is going to be just below one standard deviation to the left of the mean. Well, now we can actually calculate it. Let's think about it. We're calculating a proportion. Do we use inverse norm, or do we use normal CDF? The answer is normal CDF, because it's a proportion. So when we go normal CDF and work out the actual proportion, we type in -e to 99, because that accounts for the possibility that, you know, the stapler breaks right away. Again, the calculator, because normal distributions go to positive infinity and negative infinity, you can't say 0 there. I know it's tempting to, but as far as your calculator is concerned, there still is a small probability below 0. I know it doesn't make sense in context, but your calculator calculates that way, and the normal distribution is based around it. The Gaussian distribution doesn't stop at 0, even in context. So we need to keep that in mind. And the upper bound will be 3 years, because anything over 3 years, the manufacturer doesn't care. If it lasts 3 years and 1 day, sorry, warranty isn't available. And of course, we know our mean and standard deviation, 3.42, and we also know 0.4, so we can calculate the proportion, or the probability of a stapler actually being faulty and us having to replace it. So we go second function, distribute, then we go down to normal CDF, and then we go to 3.42 and 0.4, so our lower again is negative E99, our upper is 3, mu is 3.42, standard deviation is 0.4, so we paste that, and we get a probability of 0.14685, and I'll go to a decent amount of decimal places here, but I think you get the point. So when we think about this, this is 0.168591, so it's a very, very small proportion of staplers, so that's just over 1 in 10 when you think about it. It's probably 1 in 9, 1 in 8 we're getting to. In fact, it would be even more than 1 in 8. But still, it's a small proportion of staplers when you think about it. So now, what we can do is we can go, well, okay, that's the probability of a stapler breaking. So now let's consider what happens if a stapler breaks. So first off, we say that that is a proportion of 2,000. So we're going to have to multiply it by 2,000. We're going to have to say that proportion multiplied by 2,000 to work out the number of faulty staplers. And what happens if they get a faulty stapler? Well, we have to replace it. So it's going to cost us an extra $5. Because, of course, we have to give it to them for free. We don't get that $5 back, unfortunately. Because we offered that 3-year guarantee, so we have to suffer the consequences. So now we calculate this. And again, we get the replacement cost from this. So it's 0.41, which is a probability, 0.1416891. And I'll just write this so it actually fits on the board. As I said, times 2,000 times 5 there. I'm sorry that my handwriting is a bit wonky. Yeah, it still is. Wow. I should probably draw the line back up so I don't write over it. There we go. That will do. That will do. And from that, we can calculate a value for the replacement cost. So I'd just like to go second function answer on my calculator. Then times by 2,000, times by 5. And we get the cost to us. Now, it's going to be a very specific cost. However, what we're going to do is we're probably going to round it to, say, the nearest dollar. Because it's probably as precise as we need to go in this circumstance. So the replacement cost, as we worked out, it's obviously going to be that 0.14685 times by 2,000 times by 5. And for this, I get a value of 1,468.5. In fact, I'll round that to $0.6. So now, when I think about it in context, I'll just put that as $1,469. So now we have all our values necessary to calculate this. And in order to do so, we simply substitute this into the last bit. So we have 1,469, and we can calculate the amount of profit, the amount of money that we actually make as a stapler company after doing all the things we need to do. So we go 40,000, take, and then we go 10,000, which is our operating cost, and then we take 1,469, and we get that our actual profit is equal to 28,531. Now you may get a slightly different answer depending on how accurate you are, and I'll just tilt the camera down slightly, but there is the amount of profit that we actually get based on our calculations that we've done. So hopefully it made sense. We found a proportion under the curve which doesn't suit the warranty. We've thought about the cost, what that means in context. We've calculated our actual operating expenses and such forth, and we got a value at the end of the day. So one last thing to consider, and that is how likely it is for a stapler to break twice. So we know that the probability of getting a stapler to break once, if someone were to pick it out, is roughly that. So if they were to try and get the same one the next time, we would multiply the probabilities, because we want them to get a broken stapler and a broken stapler. So if we multiply those two together to get a rough estimate, and I know that that probably is, yeah, that should be 6, 5, 8, 6, oh no, yeah, put that to 9, just based on the last value with my rounding there. But if we were to calculate that, we would get something like 0.02149. And because of that, it means it's highly unlikely for someone to get a dud stapler twice. 2 in 100 is the probability. So again, that gives you a little sense of context, because of course it says a maximum of 1 replacement is assumed. However, in theory, you can actually have 2 replacements. And it gets even smaller with 3 replacements. Let's consider 3 replacements as well. So we have 0.14695 times by 0.14659, times by 1.59. So let's start with a calculator. I'll go second function answer and just times it by that value. And we get that it's 0.003 likely, or that's the probability of that actually occurring. Which again is even more unlikely. But it's still a probability. Someone could be very, very unlucky and get 3 dud staplers in a row. I doubt they'll probably use our brand again, but you know, it's something we need to take into consideration. So it may not actually be our profit, but based on the value given and the context of the question, that is what we calculate. We calculate what the question is asking us for. So thank you very much for this question. Hopefully it's been interesting to consider these values and these sorts of questions, and how stats can be related to a multitude of different things. Thank you for listening, and if you have any questions, comments, leave them below. Thank you.